everyone, and today we'll be seeing a quick tutorial on how to do fluid flow simulation for the internal flow on Solidworks. So basically, if I have created this duct and I want to analyze the fluid flow inside it, so obviously there will be no closing here and at the end, but SolidWorks demands that you must have inlet and outlet closed using lids. So if you want to create the lid, you basically, if you zoom in, so you check at the cross sectional area. So this is the cross sectional area of my duct. So basically you just auto generate the lid by clicking on that and go to the flow simulation tab, and then choosing here create lids. As you can see, it says closes the openings with solid lids. So you just click on it and this face will be appear, right? So how will you create a project in SolidWorks flow simulation? Click on the wizard. I'm going a little fast because this will be a quick tutorial. Next, you choose the unit you are comfortable working in. I'm comfortable in SI units. Internal flow, exclude cavities without flow condition because I don't want the solution to take much more time, but if I do that, it will just make the number of iterations more and will take more time. Now next I select the gas, which is air. Laminar and turbulent flow, no further properties, because if I select them then I have to define them, and this will again complicate the solution. Next, now this will create a computational domain about my model. Next step, we have to insert the boundary condition at these faces. So just right click, insert boundary condition. Now again you have to select the boundary conditions at the inner face of the lid of the inlet, and you going to, maybe you have volume flow rate. I'm giving it a value of, let's say, 30 meter cube per second. And at the outlet, if I want to insert boundary condition, I follow the same steps. That lid, this is my inner side. As you can see, it's it's pointing inside, so internal. If you're not selecting it this way, so it will keep on giving you the error that face is lying outside the computational domain, since you are doing internal flow analysis. So I don't know what is the volume flow rate. If you know, then it's good, but if you don't know, then simply give it a static pressure, because you know that outlets are usually at atmospheric pressure. So after that, you create a global mesh on it. A global mesh will be created like, it's not a very fine, not very coarse. So you can basically run it. You can actually select number of iterations and the model you want to solve by going into the settings, and when you run it, you see that this window appears. It will first generate the mesh and then it will solve it for different iterations. Okay, so the calculations will be finished, and you can see there are 160 number of iterations. So now I want to see results, right? So just you will expand this, and there are many possible options which you can explore, but I go with the flow trajectories because it looks beautiful, and mostly it is for the demonstration purpose. Now again I need to select the faces. I will select the same way, uh, inlet, inner and outlet, inner sides, and then I go with their line with arrows because I want to see them. So if I generate it for the pressure, so it will be generated like this. The pressure is high at the inlet and it will gradually obtain a uniform value for this uniform cross-sectional area with no disturbance, because I have a disturbance here. And if I can also see the velocity plots here, or velocity trajectories for y-axis, as you can see the velocity will be slight less, or you can say not slightly less, but comparatively less at this portion, and will increase as there is no geometry change inside this duct. Thank you very much. I hope you have understood a little bit about this simulation. Thank you.